we are going to see about practical strategies for extreme missing data imputation in dementia diagnosis. Now we are going to see about the overview of our project, that is the abstract. The main objective of our project is to remove the missing data from our dataset and to predict the dementia based on symptoms using different machine learning algorithms. Accurate computational models for clinical decision support systems require clean and reliable data, but in clinical practice, data are often incomplete. Hence, missing data would arise not only from training dataset but also test datasets, which could consist of a single undiagnosed case and individual. Alzheimer is a type of dementia that causes problem with memory, thinking, and behavior. Symptoms usually develop slowly and get worse over time, becoming severe enough to interface with daily tasks. Dementia is a general term for loss of memory and other mental abilities severe enough to interface with daily life. It is caused by physical changes in the brain. The system is developed the two different machine learning algorithms for predicting the dementia. Before that, they have removed the missing data from our dataset. The result shows that some performance metrics such as accuracy, sensitivity, specificity, precision, and correlation for our input data. So this is the overview of our project. This is the flow of our project. First, we have to take the dementia dataset from some dataset repository like UCI, Kaggle, GitHub, and so on. After that, the selected input dataset are carried out to pre-processing step. In this step, so this is the major part of our project. So in this step, we have to check any missing values from testing and training data. If you have any missing values means we have to replace that missing values by calculating the mean or median value. Then label encoding means we have to convert the string into numeric integer value. Then we have to drop the unwanted columns, that is the unnecessary columns. The pre-processed data are carried out to data splitting module. Here we are splitted the data test and train. Test is used for prediction and train is used for evaluation. So the splitted data are carried out to classification module. Here we are implemented two different machine learning algorithms such as support vector machine and random forest. In existing system, support vector machine is presented. So in proposed, we are implemented both SVM and random forest. Then we can conclude to conclude that we can compare the both machine learning algorithms and conclude that our proposed random forest is efficient. The classified data are carried out to estimate some performance metrics like accuracy, precision, recall. Then finally prediction. So here we have to predict, we are predicted the dementia or non-dementia based on symptoms. So this is the flow of our project. Now we are going to see about our demo part. So this is the output of our project. We are running our project in Spider IDE from Anaconda Navigator. So this is the data set. Here we are displayed some sample of data from your data set. After that, pre-processing, here before handling missing values, they have the so many missing values is present in different attributes, so we have to remove that missing values. So after handling missing values means so it already converted 0 0 0. Then label encoding. So before label encoding, this column which is present in our dataset actually the string, so we have to convert that string into numeric integer value. Then data splitting, so this is the total number of data, so then this is the total number of test data, and this is the total number of trained data. So after that, the feature selection, that is the correlation. So just we have to correlate the one attribute to another attribute. Then this is the performance analysis for SVM and random forest. So when compared with two algorithms, so the random forest gave the best result, that is the 95 percentage. Then the prediction, so based on symptoms, yeah, we are taken the test data, so just we have to display some sample of data. So dementia, non-dementia. Then comparison graph for SVM and random forest. So we conclude random forest is efficient, that is the proposed algorithm. So this is the output of our project. Thank you.